Good morning students, I am your Nagini ma'am. Today I am going to discuss about the density problem students, second problem part 2. Already in the part 1 video already discussed one problem students, how to find the density from solid state lesson students. This is from solid state, okay na, solid state lesson, clear? Solid state lesson, okay. So from solid state lesson students, this one, okay. Now I want to find a density problem. Second problem, see students, an element has a body centered cubic structure with the edge length is 288 picometers. The density of the element is 7.2 grams. How many atoms, grams per centimeter cube, how many atoms are present in 208 grams of the element? Okay now, so we have to find the, first of all, how many atoms are present in 208 grams of element. So here in this weight, how many atoms are present, they're asking. So first you have to find the molecular weight of the element students. Molecular weight you have to find. Based on that, so in that molecular weight, how many particles will be there, how many atoms, Avogadro number of atoms will be there. In this weight, how many atoms are there, we have to find. Clear the students question? So first I'm going to calculate the, first I'm writing density formula students. Density is equal to Z into M by A cube into Na. Clear? Now I have to find molecular weight. So molecular weight is equal to formula, what we can write, D into A cube into Na by Z. Clear this one, by Z. So molecular weight is equal to density, how much students? Here density how much given? 7.2 given. Okay, as it is substitute. A value how much given students? Edge length 288 picometers given. So A is equal to 88 picometers. You have to convert this into centimeters. So 288 into 1 picometer is equal to 10 power minus 10 centimeters students. Understood amma? So 1 picometer is equal to 10 power minus 10 centimeters students. This value I am taking. So we have to convert edge length in centimeters students. Okay na? Next substitute na, this one, edge length is equal to how much students? 288 into 10 power minus 10. This is whole cube kada, edge length, that's why a whole cube. Na is Avogadro number 6.022 into 10 power 23 divided by Z value. It is Z value how much students? It is which one? Body centered cubic structure given. That means BCC given. In BCC what is the Z value students? 2 nama. So by 2. Clear this one, by 2. So molecular weight is equal to, you have to find it. So 7.2 into 288 whole cube into 10 power minus 10 whole cube means minus 30 into 6.022 into 10 to the power of 23 by 2. Clear this one. So M is equal to, what we can write students? 7.2 into 288 whole cube. So first you have to find the 288 whole cube. Now I am taking calculator. See students, 288 into 288 again 288. Okay, then how much you got? 23887872. 23887872, we got answer. Okay now, so into 10 power minus 30, 23 means 10 power minus 7, okay, into 6.022 divided by 2. Clear this one. So here 10 power minus 7, to cancel this one I am taking the after 7 digits decimal point. 1 2 3 4 5 6 7. Clear? So how to take students? M is equal to, I am taking M is equal to 7.2 into 2.3887872, okay, into 6.022 whole divided by 2. Then M is equal to what you will get students? Understood amma? To cancel this one I am taking the 7 before decimal point after 7 digits. See here, 1 2 3 4 5 6 7. Are you following? So here left hand side you have to take the decimal point. We have to move the decimal point. After 7 digits you have to take the decimal point. That's why you are taking 2 point. Here 10 power minus 7 is cancelled. Clear this one. So this is a this is molecular weight. So here how to find it students? M value, see here, what given? 7.2 into, calculate this one, 7.2 into, okay, next 2.3887872, okay, 2.3887872 into 6.022. Clear? So this value divided by, now we have to do division, divided by 2. Okay, then how much you got, students? Divided by 2, how much answer? 51.78 we got answer. 51.78. Clear this one? 786 we got, 786. So we can write it as 51.79. Adhaitama? Understood nana? 51.79. This is which one, students? Molecular weight, gram per mole. Clear nana? Molecular weight we find calculated. So in this molecular weight 51.79 grams per mole of an element contains Avogadro number of atoms, students. But question is, in 208 grams of element, how many atoms are there? You have to find it. Clear this one. In 51.79 grams, how many atoms will be there, students? Avogadro number of atoms, correct? So you have to calculate first. See here, 51.79 number. See here, 51.79. So 51.79 grams, 51.79 grams per mole, okay, of an element, of the element contains how many atoms? 6.022 into 10 power 23 atoms will be there, correct? It contains, this is equal to the 1 mole kada. So we know that 1 mole of an element contains Avogadro number of atoms according to the mole concept applications, correct? So 1 mole of the element weight is 51.79. It contains Avogadro number of atoms. So question is, in 208 grams of an element, how many atoms are there? Asking question. So how to find it? In 208 grams, correct? So in 208 grams of an element, okay, grams of an element contains how many atoms? X value have to find. Cross multiplication, students, is like this. Now x into 51.79 is equal to 208 into 6.022 into 10 to the power of 23. Clear this one? X into. Now x is equal to, how to find it, students? 208 into 6.022 into 10 to the power of 23 by 51.79. Understood, Amma? This by this one. So x is equal to, how to find it? See here, 10 power 23 as it is I will keep. This one only I am going to calculate. Okay, now see, students, 208 into 6.022 again, 022, next divided by 51.79. Clear? How much, students? 24.18. So answer is 24.18. How many atoms are present, students? 24.18. Understood, students? How many atoms are there? 24.18. Okay, so I am taking here x is equal 24.18 into 10 power 23 as it is I am taking. So these many atoms are present in the 208 grams of an element, students. Clear this one? So 208 grams of an element contains how many atoms, students? It contains 24.18 into 10 to the power of 23 atoms. This is the question. Understood, students? Are you understanding? So this is the density problem, students. This is the part 2. Okay, in part 1 I discussed another one model, density problem. This is the second model, students. We have to find the molecular weight. First we have to find. Next, in this weight of the element, how many atoms are present? That is the actual molecular weight of an element we calculated. So in this in 208 grams of element contains how many atoms are there? We have to find. So density formula, m value we are going to calculate. 1 picometer, edge length given in picometers, you have to calculate in centimeters. Okay, now 10 power minus 10 centimeters, then substitute, you will get value. Molecular weight is equal 51.79. Clear? So that means 51.79 grams of an element, gram per mole of an element, it contains how many atoms? This many atoms. Avogadro number of atoms. In 208 grams of an element, x, how many atoms are there? You have to find it. So then you will get 208 grams of an element contains this many atoms. Okay, students, I hope you like this video. Thank you, students. If you like this video, please like, share, comment and subscribe my channel, students. Thank you, students.